Hello guys, good afternoon. Am I audible? Please guys respond in chat. Am I audible? So guys, two sessions are done. We'll be doing now third session. After this, we'll be doing other aptitude and propulsion and sessions. Yeah. So guys, quickly respond. Yeah, done. So hello everyone. Welcome you all in iitiansgateclasses, and these are IGC's different courses for GATE Aerospace Engineering. Those who are passing engineering either in 25, 26, or already have passed. So we have GATE online coaching program. Our first Fab batch, is going to start from tomorrow. We have another target GATE course, which is recorded course. We also have GATE online test series, distance learning program. Apart from that, we also provide GATE crash course, which starts from November first week. Now, guys, come to the point. So, in today's session, we'll be discussing GATE 2024 Aerospace Engineering question paper solution in detail. And myself, Dinesh, I'm an organizer for IGC, come chief educator at IGC. And most of you know me well, being being organizer at IGC. Yeah. So next session we'll be discussing general aptitude. Okay. And guys, currently you cannot decide which is for 1 mark and which is for 2 marks. Of course, you guys might be having idea because many of you have written question paper also based on the question. It's lengthy or very simple. You can judge 1 mark or 2 mark. Otherwise, during official key release, they will release the paper also. There they will mention, marks corresponding to each question. Clear? So, guys, from aircraft structures, if you take basically they ask one questions from thin walled structure and one from aircraft structures basics from compatibility equation. So thank you, Abhishek. You told you just watched my compatibility equation session and you could solve that question, right? Before 1 day before exam. So I have provided one simple and good lecture on compatibility equation and Airy stress function on YouTube, which is available, and I think thousands of people have used. Maybe 4,000 views are there on that. Okay. Fine. So let's see this question. So Abhishek, what is your answer? Am I audible, guys? Quickly say yes or no. Okay. So in this problem, guys, read the problem. What it says. Consider the plane strain field given by, and I'm happy to say most of the 2024 problems, yes, you seems to be fine. Most of the GATE 2024 problems are from our formula sheets. If you refer just our formula sheets, majority of the question you can solve. So what is given? Let's see the question. Consider the plane strain field given by epsilon xx equal to 10 xy square, epsilon y equal to minus 5 x square y, and gamma xy equal to a xy bracket 2x minus y, where a is a constant, gamma xy is the engineering shear strength. The value of the constant a for the strain field to be compatible is. So guys, first they given plane strain problem. So plane strain is a 2D problem. Okay, it's a 2D stress problem. So in case of plane strain problem or any 2D stress problem, we know what is the compatibility equation. The compatibility equation is given by what? Dou square by dou x, dou y, gamma xy. This is equal to what? Dou square upon dou y square epsilon x plus dou square upon dou x epsilon y y, right? So this is what non-zero compatibility equation for a 2D stress problem. Okay, and we know plane stress and plane strain problems are 2D problems. Now guys, in this problem they already given gamma xy, epsilon yy, and epsilon xx in terms of x and y. So guys, just substitute these and differentiate with respect to x and y, and then simplify, you will get your answer. So let me first substitute gamma xy in this and then differentiate with respect to x and y. So before that, gamma xy equal to axy into 2x minus y. So I can write it as what? Gamma xy as it is 2ax square y minus ax y square. Okay. Now guys, substitute and differentiate. What you get? You will get 4ax minus 2ay, right? This will be your what? Left hand side. Now if you see the right hand side, substitute guys epsilon xx and differentiate, it is square. Dou square, dou y square, and dou square by dou x square. Guys, please look into this. Now substitute guys gamma xy, sorry, epsilon xx, and then differentiate twice with respect to y. So what we will get? We will get 20ax. Am I correct? Again guys, epsilon yy is given as minus 5x square y. Now differentiate this with respect to x twice. What you get? And already minus sign I can take here. So it is minus 10ay. Now guys, from this, not here a is not there guys. Just sorry. It is 10x and then minus 10x minus, sorry, 20x minus 10y. Okay, please guys, be careful. Okay, now guys, what you can do, you can take a out from here and you will get 4x minus y, and from here you can take 5 out, you will get 4x minus y. So this is cancelled, this is cancelled. So from here you guys find a equal to 5. Very good guys. So it was a very simple question and there is no calci required, not much of calculation, and a is 5. Okay, so 5 is a correct answer. I think this question should be for 2 marks. Okay, so those who have done it, this is one of the NAT, easy NAT, and I believe the people might have done correctly. Okay. Mhm. Okay, I think that question is not mentioned here. Okay, this is one of the strength of material question, but there is a thin walled structures question. Okay, let me write that question and we'll solve. Okay, instead of doing this question, which we will do in strength of material, let me do that question. Okay. So question number 45 guys, from thin wall structure. So what they have given, the cross section of a thin walled beam with uniform wall thickness shown in the figure is subjected to a bending moment mx equal to 10 Newton meter if h equal to 1 meter and t equal to 0.001 meter. The magnitude of maximum normal stress in the cross section is, they asked the sigma max. Okay, and the answer they asked in Newton per meter square. Now for this they have given diagram. It's a C section, channel section, and this is what your x-axis, and this is what y-axis. Now they have given this height h, and this dimension h by 2. This is also h by 2, and the thickness, uniform thickness, it is t. So guys, this question is visible and I'm audible. Anybody can tell me the answer for this, guys? So again, this question, guys, from Thin World was very easy question, and without doing any calculation, without using calci, you can answer. Okay. So first, in this case, guys, tell me, it's a Thin World bending question, right? So what is the IXY, product moment of inertia for channel section? Anybody? Product moment of inertia for channel section. Since it's a symmetric section for x about x-axis, so IXY is 0, right? And in here, My, the moment about y-axis is also 0. So your bending stress, sigma z, it will be, guys, here sigma z. So sigma z will be what? A simple bending formula, which will be what? Mx upon Ix into y. Why it is 0, Abhishek? It is not 0. Okay. So this is what your bending stress. Now guys, here where bending will be maximum and from where y is measured. So y is always measured from centroidal axis, and we know your x is what? Centroidal axis. So your bending stress will be maximum on top and minimum on bottom. Okay. So on top it will be like tensile. Okay, if you have mx like this. Okay, so when it is maximum at top. Okay, okay, Abhishek, got it. So what is y? So y will be equal to h by 2. Okay, mx is given. Now guys, tell me what is unknown. Unknown is what? Ix. Now guys, we need to find just Ix, and also Ix is very easy for this channel section. So we all know, guys, for channel section, and in case of thin wall, higher order term of thicknesses are neglected. Now guys, here there are three member, 1, 2, 3. So for this vertical member, we already know this is centroidal axis. So what will be Ix? It's all directly THQ by 12. So it is THQ by 12. Now for this flanges, these flanges, your Ixx about its own axis will be neglected because it will be h by 2 tq by 12. Okay, so those will be neglected. So only there will be contribution due to what? Parallel axis theorem. Okay, so that will be what? For bottom and top I can multiply 2, then 2 into area. Area is what? T into h by 2. And what is the distance between parallel axis? It is h by 2. So you can write plus minus h by 2 square. Now guys, when you simplify, this will be coming as what? If you just simplify, guys, it will be THQ by 12 plus THQ by 4. So we will get THQ by 3. Okay, so guys, now you got Ix, and Y is already known, right? Y is already known, Mx is known. So let's substitute everything. So what we get? Sigma Z max. So sigma Z max will be what? M. So M is how much? 10 Newton meter. Ix. So T is how much? 0.01. H is what? 1 cube by 3. Now what is the y? It is h by 2. So it is 1 by 2. So what we get? We get 15 by 0.001. So what is the answer? Anybody can tell me what is the answer? 15 into 10 to the power 3, yes or no? Newton per meter square, which is nothing but what? 15,000 Newton per meter square. So guys, now look into this question. Have I used anywhere else Kelsey? This question is far simpler than many of the previous years question from thin walled structure. So what is the maximum bending stress, guys? Anybody got this correct answer? 15,000? Yes or no? I think many of you have not attended this question. I have seen some of the responses. Okay, so this was second question from aircraft structure. The previous question which you guys can see here, it is from strength of material. I can tell the answer. It is the summation of principal stresses they asked, and you can see the orientation is 45 degree and there is no shear. So these stresses, given stresses, are principal stresses, and the summation will be 10 minus 10. So you can see it is sigma 1 plus sigma 2 is what? 10 minus 10. The answer is 0. Okay. So I think I don't think paper was lengthy. Okay, the questions are quite straightforward for all subjects. Only in SOM there is one good question. Okay, so that's for aircraft structures part, guys. Now from mechanical vibration there are total 3 questions, guys. Okay, so guys, read this question. What it says: for a single degree of freedom spring mass damper system subjected to harmonic forcing, the part of the motion that decays due to damping is known as. So guys, we know forced vibrations. Okay, forced vibration of single degree of freedom system. So what is the equation of motion for forced vibration, guys? It is mx double dot plus cx dot plus kx equal to f naught sine omega t, right? With simple, harmonic excitation or harmonic forcing. Now guys, here this is what single degree of damped forced vibration. So in this case, guys, the solution of the motion is given by what? X equal to xc plus xp, right? Anybody know what it is? Xc is corresponding to what? Complementary function, and this is what? Particular integral. So this part represent what? Transient response of the system, and this represent what? Steady state response of the system. So this is what? Transient, and this is corresponding to what? Steady state response. Now guys, in case of transient response, we already know how we solve this transient response part, complementary function, by removing the force. So how we solve, guys? You all know, right? Mx double dot plus cx dot plus kx equal to 0. Now guys, what equation this equation stands for? What we all know, Abhishek, this equation stands for what? It's damped free vibration, right? And this damped free vibration is also known as what? Transient response. Okay, in case of forced vibration. Okay, now guys, if you plot it, forced vibration, so this transient response part, okay, and then you have steady state response. Clear? Everybody, is it clear? Yes or no? So Abhishek, you are correct, and others also correct. Okay. So what is the answer? So in this case, B is the correct answer. B is the correct answer. Guys, again, This is very simple question. You guys can find in our formula sheets, or you guys just refer Grover. They have given this. No, no, Abhishek. The motion will be combined. Okay. The motion will be combined. The transient plus steady state. Okay. Let's move to next question. Yeah. So this is another question from mechanical vibration, guys. Okay, and most of you should be aware of this. And again, simple question. These all plots are there. If you just refer IGC's formula sheets of mechanical vibration, so read the question what it says. I think no question in that this year. Okay, from aircraft structures module, except I think one question they asked, like combination of engineering mechanics come strength of material, that trust kind of question. Anybody have done that trust kind of question? I'm asking, guys, how many of you have done this trust question? Anybody did this question, guys? Anybody did this question, guys? Can anybody tell what this question actually? We will solve anyway this question in SOM, strength of material. Anybody can? Basically, this question belongs to what? Which topic? Yeah, Neil, we will see that question. Before that, I'm asking. So this question, I'm just giving guys clue. This question belongs to what? SFBM. Okay, shear force and bending moment problem. The only thing here, you have to find what? Reactions using fundamentals of, no, it's not exactly truss usual. It's a combination of truss and beam problem. Okay. Okay, let's move to frame question. Actually, this is like landing gear. The aircraft landing gear can be idealized like this. Okay, not exactly Neil. It's a frame. Okay, yes. So let's see now question number 22nd. So question number 22nd says what? Consider the free vibration responses P, Q, R and S of a single degree of freedom spring mass damper system with the same initial conditions for the different damping cases listed below. Which one of the following response is correct? So guys, if you see the case of Q, you can see in the case of Q, there is no change in amplitude. So it's a free vibration. So free vibration means undamped. So your Q is corresponding to 4. Okay? Q is corresponding to 4. Now guys, there is R, which is what? Oscillatory, right? So we know oscillatory motion happens in what? Under damped system. So R is corresponding to what, guys? R is corresponding to 2. So now guys, tell me which can be the correct answer. Either B or D can be correct. Now guys, look here. We already know guys, in case of critical damping, the system will comes to rest in what? Minimum time. Now you guys look guys, this P and S, which is taking more time to come to rest? Which is taking more time to come to rest? Anybody? We know critical damping is what? The case for which the system take minimum time to come to rest. right? So that means P belongs to what? 3, critical damping. So what is the correct answer? D. P is what? Critical damping. Q is no damping. R is what? Is underdamped, and S is what? Overdamped. You can see S, this, it's a overdamped. So more the damping, more sluggish will be the motion, and system will take more time to come to rest. So this is what simple question number 22nd. Okay, so guys, go on and refer your basics, you guys will get answer. So D was the correct answer. Now this is last question, question number 37. So this question, guys, again, if you just refer IGC formula sheet, you can solve this question, guys, because in IGC formula sheet we have given the equation of motion for 2 degree of freedom system. Also we have given the equation for frequency, how to find frequency for 2 degree of vibration. So guys, you can see there are two equation of motion for 2 degree of freedom. So first, guys, we know what is a 2 degree of freedom system, spring mass system. So it is usually denoted like this. There is a mass m1, this is k1 spring, and this is what? K2 spring, and this is mass m2, and this is what? K3 spring, guys. Now, guys, this is what? Response of mass m1, and this is what? Response of mass m2. Now, guys, for this spring mass system, if you have learned 2 degree of freedom system, you should be knowing equation of motion. Equation of motion. Those are very easy, guys. You can derive also using Newton's method, or you should know. So what is those equation of motion? Yeah, 1.73 Neil is correct answer. Even you just refer Graver. You need not to solve anything. This is the standard case. What is the standard case, guys? In this problem, we will be finding K1 equal to K2 equal to K3 equal to K. Okay, K1 equal to K2 equal to K3 equal to K, and you will also given M1 is equal to M2 equal to M. Now this is a standard case. For this case, no, Srivastav, 1.41 is wrong. Okay, so for this case, the natural frequencies is given by what? Under root 3 under root k by m and under root k by m. So this is what lowest natural frequency, this is what highest natural frequency. Now, guys, let's solve this question. So, guys, we know for this 2 degree of freedom system, how the equation of motion is given by? It is m1 x1 double dot plus, guys, k1 plus k2 into x1 minus k2 into x2 equal to 0, first equation. And what is the second equation of motion? It is m2 x2 double dot, then what? Minus k2 x1 plus k2 plus k3 x2 equal to 0. You all know, right? No, no, no. Sai Lakshmi, you cannot. How it is round up to? Did they ask nearest integer? They didn't ask nearest integer, right? You cannot answer 2. They asked in what? 2 decimal, right? Round off to 2 decimal. So you cannot round up to, integer. Fine. Now, guys, if you compare these two equation with given, what we find? We find m1 equal to m, m2 equal to m, then what we find? K2 equal to k, and also we know k1 plus k2 equal to 2k. So from here what we find? K1 equal to k. Same way, what we got? M2 equal to m, then, guys, k2 equal to k, and same way what we got? K2 plus K3 is given as 2K. So from here guys, we what we found, k3 equal to also k. So clear now? Yeah, SOM will be also done today. Is this clear guys, what I have told? This problem corresponding to this condition for 2 degree of freedom system. Now guys, what frequency equation we know? It is given as what? M1 M2 omega power 4 minus guys M1 into K2 plus K3 plus M2 K1 plus K2. Yes, it is correct. K1 plus K2 into M2 omega square, then plus K1 K2 plus K2 K3 plus K3 K1 equal to 0. Now guys, you know everything, M1, M2, K1, K2, K3. Substitute in this equation. When you substitute everything guys in this equation, what you find? You find guys M, what you guys find? M square omega power 4 minus 4km omega square plus 3k square equal to 0. Now guys, assume omega square equal to x, then it will become an quadratic, it will become a quadratic equation, which is what? M square x square minus 4km x plus 3k square equal to 0. Now guys, solve x value, which we know from Dharacharya's formula. Dharacharya's formula, what it says? Minus b plus minus under root b square minus 4ac by 2a. Now using this, if you solve, substitute, what we find? We find this b is what? Minus 4km, so it will become plus, so 4km plus minus under root, so it is what? 16k square m square minus 4ac, so it will become 12k square m square, then by 2 a is what? M square. Okay, so now guys, what will be the value of x? Those will be 4km plus minus 2km by 2m square. Now guys, they ask the highest natural frequency, so you will take plus or minus. So guys, those who are watching this session, if finding session is useful, can thumbs up. Clear? So in this case guys, if you take plus, it will become what? 6km by 2m square. So that means x is nothing but omega square. So omega square is what? 3k by m. So from here, the highest natural frequency, omega highest, is what? Under root 3 under root k by m. So what was asked? Alpha, right? What was asked? Alpha. So what is the alpha value guys? It is coming under root 3. So under root 3 is nothing but what? 1.73. So the answer is guys what? 1.73 or 1.71, right? What is, no, 1.73. Under root of 3 is 1.73. Under root of 4 is what? 1.41. Clear guys? So that's all from vibration question guys. Okay, so this was also easy question. So now guys, these are our details for upcoming batches for gate 2025 and 2026, and these are our previous track records. Okay, and these are our PSU achievers. So guys, IGC is currently number one institute in India for gate aerospace learning. And thank you all guys for watching this session. So whoever interested to take any support from IGC can reach to these contacts. And guys, next session is for aptitude, and guys will be solving all the aptitude question. And you guys can join our Telegram group or can follow us in different social media platform for future updates. Thank you guys. So next session will start in a while. Okay guys, thank you all. Thank you guys.